Number 6. So the figure below shows the displacement time graph for a certain wave. So we want to have the wave here. This is displacement. We have time in seconds. This, as I said, is to guide us. So that's the wave. Then we have been given the following for the wave. We have been told that this point is 7.0 times 10 power negative 3 seconds. Then we've been told at this point is 3.5 times 10 power negative 3. So that is what we have, and we are told determine the frequency of the wave. So here is the question. So we've been told the figure below shows the displacement time graph for a certain wave. As we can see, we are told to determine the frequency of the wave. And we have been given time at this point and also at the other point. And we know that frequency refers to the oscillations in 1 second, or number of oscillations in 1 second. So as we can see here, how many oscillations do we have? We can calculate and see the number of complete oscillations for this wave. So we have this. This is 1, 2, 3. So we have 3 waves. That is 3 complete oscillations. 3 complete oscillations. And they are being covered in 7.0 times 10 power negative 3 seconds. So we have 3 oscillations in 7.0 times 10 power negative 3 seconds. And now that we know frequency is the number of oscillations in 1 second, we ask ourselves, what about in 1 second? How many complete oscillations, or how many oscillations are we going to have? And that will be our frequency. So we are going to have 3 times 1 divided by 7.0 times 10 power negative 3. So we can calculate this using your calculator. So we are going to have 3 divided by 7 times 10 power negative 3. So what do you end up getting? So we can write it to 2 decimal places. So we are going to have 428.57. And this is frequency. So it is 428.57 Hertz. So that is what we are going to have for that, 428.57 Hertz. So because the number of complete oscillations here are 3 in 7.0 times 10 power negative 3 seconds. So in 1 second, we want to know the oscillations. There will be 428.57 Hertz. So that will be our frequency.